Hello everyone and welcome to today's session. Thank you for joining us for today's workshop and my name is Rabih Kanaanis. I'm part of Bambocon, an equity crowdfunding platform for tokenized securities. We are on the hunt for very exciting startups with groundbreaking solutions who can benefit by coming onto our platform and reaching out to a larger audience. Startup founders, experts, investors, or any other stakeholders can participate through our platform. Today, we are hosting a workshop on computational thinking, a fundamental skill in this digital age, presented by Rabih Kanaanis, the founder of NowMatters based out of Sweden. He's also going to be joined by Christopher Lundgren, the leading investor analyst, and Professor Fidel. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the private box on your right. I'll bring them up at the end of the presentation for a quick 10-minute Q&A. Over to you, Rabih. Can you please unmute yourself?
Here we go. Can you hear me now?
Yes, better.
And you can see my screen?
I'll just be sharing that.
Give me a signal when you can see it.
Yes, you can go ahead.
All right. So my name is Rabih Kanaanis. I'm the founder of the NowMatters Academy. We're going to discuss today our journey into computational thinking and STEAM and how we can prepare students for 2030. It's a hot topic right now, and we're going to share our journey. And you're going to join me today, my colleagues, Christopher Lundgren, based in Stockholm, Sweden. He's a leading investor catalyst, what we call him in Europe, Mr. Enterprise. Pablo Martinez Lopez, who is a professor at University of Quilmes, and also he's a computational thinking tool builder for over 10 years, and he's going to do a demo for us today. He's my colleague and our partners with Program.ar and the Sadowski Institute. Dr. Pierre Gedron is with us, but not live today. He's based in Beirut, Lebanon. He's head of our office in Beirut. And myself, Rabih Kanaanis, the founder of NowMatters, based in Stockholm, Sweden as well. We're dividing our presentation into 4 sections. We're going to go through them one by one. The goal is how can we prepare our students for the future in 2030 with the jobs landscape and the educational landscape moving from the traditional education that we're seeing today. We're going to study the success stories of the US and the Nordic region, their economical impact and what were their success factors. And also you're going to see our contribution to that success factor. And this presentation is more a conversation. We're going to draw, consider it as a whiteboard, like the whiteboard behind me. We're going to draw an action plan as we move forward. So we can put, for example, how can Bahrain benefit from the US and the Nordic experience, and how can they execute that action plan that we're going to build together. And it's very important that that's the biggest challenge for especially developing countries right now, with the huge demand on the educational sector, on schools to be more technologically driven, how a country like Bahrain or Lebanon or Nigeria that we are working with, they don't stay behind. They're not hampering their economic development, and also the knowledge gap from countries that already started that journey and countries who didn't start that journey doesn't get bigger and bigger. And all those topics, we're going to start going through them during the presentation. In the beginning, we have 2 definitions during the presentation we're going to go through. The first one is STEAM. People attending this seminar who are in the educational sector, they're familiar with the word STEAM. STEAM is an acronym of 5 words: science, technology, engineering, art, and mathematics. Those topics into traditional schools today are taught individually. With the STEAM approach, they are taught together in an interdisciplinary approach. And as we can see, as you know, in today's jobs, when it comes to technology and engineering, STEAM is present in almost every job description today. So basically, STEAM, instead of teaching those topics individually, we teach them together as one topic in everyday school. If we look at the US right now, an example of STEAM occupation like software developer, even customer support, civil engineering, mechanical engineering, and you can see the jobs that this is from 2019 on each of these topics. If we look at the US right now, the STEAM supported jobs are 67% of the current US jobs, is quite a big number. It's 33% of the GDP, and STEAM jobs add to the federal tax revenue every year $2.3 billion yearly, and that number is expected to grow by 7.4% yearly until 2030. So the trend already started. It's happening today. It started in the US, in Nordic region, and China, and it's gonna come eventually to developing countries. And now I'm gonna hand over to my colleague Christopher to speak a bit about the Nordic experience when it comes to STEAM.
Yes, thank you, Rabih. STEAM and education in computational thinking has been an important part of the success of the Nordic tech ecosystem. The 5 Nordic countries, that is Sweden, Norway, Denmark, Finland, and Iceland, is the world's second largest technology innovation ecosystem after the USA-based Silicon Valley ecosystem. The slide is from a recent report from the European Union that ranks Sweden as once again the European Union innovation leader, followed by Denmark and Finland. Norway is not part of the European Union, but an important part of the Nordic region. Together, the region are, if you count in the number of patents and unicorns and global tech companies, especially in the deep tech sector, larger and more important than other regions such as France, UK, and Germany. Next slide, please. The Nordic region is on its own the world's 12th largest economy. It's one of the most prosperous regions in the world, and is also the most digitalized region in the world. Next slide. The high grade of digitalization combined with the flourishing ecosystem and more than 10,000 software companies has created a huge lack of software developers. STEAM education is mandatory in the Nordic region. All the 5 countries is mandatory already from when the kids are starting school. And it's an important part of every university educations in the Nordics today. But still, depending on the high digitalization rate among the ordinary enterprises and the huge booming global software industry, only Sweden, well actually Stockholm, lacks 70,000 developers year 2021. In the western part of Europe, there is a shortage of more than 700,000 developers. This is, of course, also creating a huge opportunity for other regions in the world. If you have the capabilities to meet this supply or supply this demand, then of course there is a huge business opportunity. This situation also for having a big high-tech industry, but actually no home market, means that the Nordic companies are born global from day one, because since they don't have a home market, traditionally they need to go to very early to a new market. Traditionally that is the US market, but more and more companies is now going east instead of going west. And the combination, and I think the business opportunity for a country like Bahrain with a well-educated population is, of course, of attracting Nordic software companies to set up their business there. And that is, of course, conditioned by that the skills and the knowledge of the right programming languages and so on, of course, is a match with the demand. The supply and demand needs to be matched. And of course, there is also, of course, an opportunity to attract the Nordic companies that actually need to relocate to other geographic regions to grow. And with that said, that about Oak Island, who is a growth venture capital firm in the Nordics. And I'm the general partner there. And Nordic Apiary, who is a tightly cooperation with NowMatters, is an export firm for ecosystems. With that, I hand over back to Rabih.
Thank you, Christopher. So we have a clear objectives. We have our students and we need to teach them STEAM. We are building the puzzle right now. And this text I took from UNESCO. I will just read it as it is. STEAM is crucial for countries to build up a critical mass of scientists, researchers, and engineers to enable them to participate in a fully in the global economy. So STEAM became a requirement for any country that basically want to participate in the global economy right now. So it's very clear the objective, but the question, how to do it? The objective is very clear. We have students, we need to teach them STEAM. So what are the steps? I will introduce my second definition of the day, which is called computational thinking. Some other places, possibly you heard about it, called logical thinking. Computational thinking is a strategy. It's basically teaching students a strategy on how to solve problems and create solutions. And it has different pieces, like the composition of a problem into smaller problem, abstraction, pattern recognition, algorithm design, which basically is solution design, debugging problems, iterating solution, and generalization of the solution as well. So you can consider computational thinking as a strategy that you can implant in the child, in the students, regardless of the career. They can be engineers, they can be they can work in agriculture. It doesn't really matter. It doesn't only apply to computer science. It's a strategy used by students to take a problem, dissect the problem, find a solution, and implement the solution. And if we look at computational thinking, this is taken from Congress. In 2017, Congress said that computational thinking is mandatory to teach STEAM. And the Swedish government that Christopher mentioned before had introduced computational thinking in all their curriculum. Then we have an updated map. If we're drawing this map together, we have an action plan. We have students, they need to study computational thinking to enable them to prepare them for STEAM jobs. Moving forward, but computational thinking is very important to note that it could be taught using different tools. It could be taught using mathematics, it could be taught using chemistry, it could be taught using physics as well. But the problem in teaching teaching computational thinking with math and physics, for example, that the solutions will be abstracts. Students will not be able to see the solution. They will have to imagine them. So what we did with NowMatters, with our partners in Program.ir and from the Foundation Sadowski, we are using coding as a tool to teach computational thinking. And why are we doing that? Because when they use coding, they can see the solution, they can manipulate the solution, they can take the problem, solve it, and execute it. So, and it's important as well, and this is happening in many countries, that they take a decision, or many schools, to teach coding. They take the students, put them in class, and start teaching them syntax. Basically, what they are doing, I'm an engineer myself. I work in the public sector, building solutions for the public sector in Sweden for over 10 years and over 30 projects. You basically have bad developers, because this developer can write code, but cannot solve solutions. But by introducing coding as a tool, not as a target, but as a tool for teaching computational thinking, then we are students will learn how to code as a byproduct. They will understand why they are coding. They will take a solution and execute it. And also, when we implement computational thinking in schools, it doesn't mean computer science, because not every student in the class will end up being a developer or a system architect or a designer. Some students will end up as agriculture engineers, secretaries, mechanical engineers, but this computational thinking strategy on how to solve problems will stay with them, and they will always have the basic coding know-how to be able to understand the machines they are working with, not only being told what they are working with. So at NowMatter, if we update again the map, so we're gonna teach computational thinking to unlock the STEAM job opportunities, but we're gonna use coding as a tool to teach computational thinking. Already right now, we have, as Professor Fidel, we're going to demo later on, over 500,000 students using the tools that we work with today. We signed a deal with Lebanon 4 months ago for 200,000 students. And last week, the federal state of Kaduna in Nigeria signed a deal with us to execute our strategy for 400,000 students. So what we're going to show you today is already in place. It's already happening in Argentina, and now it's going to happen in Nigeria and Lebanon pretty soon. During the demonstration, I'm preparing right now for around a 15-minute demonstration. We're going to use the word attire. Attire is basically dress up. Here we have the same model dressed up in different suits. But during our example, we're going to use attire to use abstraction. Students in our tool, they use stones. They start coding with stones because it's fun. Here you have a blue stone, then you have 3 black stones. But when they code with stones, those stones represent something else. For example, to the right, those stones represent a farmer farming his land. And at the bottom, each stone represents a bulb. So during our demonstration, if you hear the word attire, it means representation of the stones into something else. So just keep that in mind. And now we jump into the demo. The demo was recorded beforehand for one reason, because when we tested with Professor Fidel with us on the call, there was a slight delay. So we recorded the demo, but if you have any question, you can ask us at the end. So Richelle, if you can please play the video.
In this presentation, I will talk briefly about how to teach computer science and computational thinking ideas using coding and programming. I am from the Argentina University of Quilmes and Fundación Sadowski, and working on the initiative Programar and Gobstones. So let's go. So the goals of this presentation, as I told you, is to present what we are doing in Argentina to teach computer science and computational thinking, and to show how Gobstones can be used for that. And also to highlight some of the most prominent features and possibilities of Gobstones for doing this task. Program.R is an initiative from Sadowski Foundation. It's a group of people working inside this foundation, and a joint venture between several government ministries to promote teaching of computer science and computational thinking at all educational levels in the whole country, and we expect that beyond as well, for example, in Latin America or other countries. The production of the Program.R initiative is a lot of things involving innovative didactic approaches, as some I will show you here, curriculum design for different levels, course and activities, particular courses and particular activities for different goals, and also manuals and didactic material, and finally software. So manuals, for example, are expressed for different levels of education, and the software as well can be adjusted to those different levels. So the Program.R manuals provide the access to all these ideas for teachers. So teachers can have the guide to teach the computer science and the computational thinking ideas. Manuals are based on different tools, for example, Gobstones, Pilas Bloques, and other tools that we are working on in the foundation. I will talk about Gobstones there. Gobstones is a teaching environment for programming, that was assigned at the Quilmes University in Argentina in a team under my supervision. And the tool allows using predefined activities that are defined by teachers, either as a standalone activities or grouped as a course of activities, a sequence of activities to take one after the other. And it also allows freestyle programming, so a student can experiment by itself, creating new programs and the like without the guide of an activity. It allows also coding both with blocks and with textual code, so it's easier to move people from blocks to textual code. And you can design activities for different educational levels with ease. In particular, we are using Pilas Bloques and Gobstones in Argentina to teach at secondary school, primary and secondary school, primary schools, students from 8 to 12 years old, at secondary schools in 2 levels, from 13 to 15 and from 16 to 17, 18 years old. And at university, we are also using Gobstones at university for computer science students. This is the initial language in some of the universities. For students of 18 years old and more. In this case, at the university, we are thinking about teaching professionals. In these other schools, primary and secondary school, we are thinking about teaching only computational thinking ideas as a general knowledge with no specific knowledge of programming as a professional activity. In the focus of Gobstones, in order to show you the possibilities on how to show a small course, is a demo for a course in Gobstones, so you can appreciate how the computational thinking ideas can be expressed for different levels and guide the students slowly on the construction of these ideas. It consists of several activities where students are involved to program, to code, so they can really experiment their ideas and play with them. And as the result, they learn the new concepts we are trying to teach. So a full course, of course, contains much more activities than the one I will show you, but the demo course, it contains just 4 units. In a full course, you can adjust the number of activities in order to allow different learning curves or speed of learning and different levels of education as well. So it's very flexible too. In this course, as I told you, we have 4 units. They are used for several levels, for primary school, secondary school, university. As I told you, I will not show you the university here because we are focusing on computational thinking ideas as a general knowledge. And so the units present 4 things. First, how to present basic elements, then how to express abstraction and decomposition. These are 2 key ideas in the computational thinking suite. And then how to teach other computational thinking ideas, and how to use abstraction and decomposition to produce explanations of the real world. And then how to use these ideas in order to solve more complex problems and give the students the feeling that they can program or they can produce artifacts, for example, games or applications that contain these ideas fully. Each unit is complex than the previous one, and it's intended for different levels. So the first unit is presenting basic elements. So in this unit, we will introduce the basic coding ideas. It's intended for students between 8 and 10 years old. And so we present basic elements. In Gobstones, we use stones on a board in order to represent everything. So first, I will show you in the teacher and the farmer and the Gobstones first activity. I will show you how the stones can be used to represent almost anything. And then in the following activities that I will not show you, the way to put stones and to define procedures, that is one of our basic tools for constructing these ideas, is shown how students can learn to program with commands and procedures. So the first activity present the idea of how to program or build program in gobstones, and the notion that you can change the attire, that is the way you experiment the program. For example, you can have a program that appears as a farmer planting tomatoes, or a teacher distributing candies, or the robot turning on lights. But indeed, what you are programming with is with little stones, so just numbers and colors. Okay, and this activity is presented in order to show the importance of learning the manipulation of basic elements with no a priori meaning. So this means that you can abstract your own meaning, you can impose your own meaning on the things you are programming with, and this, of course, fosters computational thinking ideas very much, because computational thinking is related with this notion of using one thing to represent some other thing. In particular, I will just go to briefly to this activity. I want you to show. I want you to see the activity working. So here you have the program, you have the activity here. I will start it, and you see that the farmer is planting the tomatoes. But if I change here and I change the attire, now it's the robot turning the lights. And if I go up and select the teacher, then you see that there is a teacher distributing the candies, but indeed they are only stones. So this is how you acquire different meanings with all the same notions of programming and coding. And with this, we will build the ideas of computational thinking stuff. Okay. So continuing, how to use these ideas to express abstraction and decomposition. So for this, we have several activities, 4 in particular in the second unit, and this is for students of 11 to 13 years old. And the ideas involved are to express domain representation, so they learn how to express domain representation. Remember, they have learned how to manipulate basic things on previous years, so now they are ready to use those ideas to really build new activities and new domains. For example, aliens, a story about warriors, or Martian repairing the spaceship. And for this, they need to put in play the ideas of domain representation, solution strategy, what Rabih called algorithm. Okay, so for example, when learning how to express abstraction relating the representation of information with this, they can program. They have a program moving an alien, but they need to make the alien to move really. So they need to know that the alien is represented as a green stone. You can observe it here. And so moving the alien is moving the green stone, and pushing the button is removing a red stone from here. So they need to use the basic commands here and get the result. But what they do indeed is thinking about an alien and moving an alien. But they are using this abstraction notion. In the other activity here, they express the composition, and this is related on how to define and express sub-problems. In this case, they had to tell a story about a princess fighting the Black Knight. And so there are a series of tasks to be performed by the princess. So they can express each of the tasks as a procedure, and so expressing really the composition and the sub-problems. If they do not use the sub-problems, you simply have a lot of basic tasks without meaning. And so this is what they do when they do not have computational thinking. But after working a bit with these ideas, they finish with something much more elaborated and expressing the composition. So they can experiment the computational thinking ideas at this stage of their education. Later, they can be taught another set of computational thinking ideas. For example, between 13 and 15 years old, students can ask themselves, how image processing work, how characters are represented by computers, and how indeed how the computers work and how it's all the technological solutions around them built. So, for example, we use coding as a vehicle for these ideas. In particular, I will show you how to convert image to grayscale and how can they experiment this. So they can see, again, using the representation notion, they can see that they can represent images using stones, and they can build the program to make some image processing, in this case, some filter. Again, I will go to the presentation here. So here I have a bigger, smaller image, but you can see that the image is represented using stone. And then I can make, with the program, I can show that the image is being processed in order to be converted to grayscale. But if you remove the attire, you indeed are working with stones. So in this way, they really experiment the computational thinking ideas in their own hands. They take the ideas in their own hands and play with them. And they also see how these ideas are used to build the world that they surround them. For example, they have these filters, image processing filters in their phones, and they use them all the time, but they do not know how they are built. So in this case, they can see that it is something that they can do indeed, and that gives them much more confidence about the power of computational thinking ideas, and makes them vinculate them and relate them with things that they see every day. Okay, so you can see here that the image is really now in a black and white or grayscale pattern. Okay, so let's return once more to the presentation. Then moving forward to older students, 16 years old students and more, they can use all these concepts they learn in order to build more complex application. For example, small text editor or small game. In this particular case, is Snake we choose. So they need to learn some other related stuff, for example, interactive programs and the like. But you can see here that they can program using decomposition, using abstraction. And with this program, they can express their ideas about applications or games or, I don't know, any application they want. And in this case, they are really using these computational thinking ideas to something useful for them. And of course, you can extrapolate this to other things after learning them precisely in the coding environment. So finishing, we think that in order to teach computational thinking ideas, you need a good didactics, that is a good sequence of activities or a good sequence of notions to be taught at every level. But in every level, you need to teach an appropriate amount of ideas. And that is why we try to express with program.r manuals. You also need a good environment, because if the environment is guiding you in wrong directions, it's not a good idea. And for that, Gobstones is a powerful tool, because teachers can use predefined course or they can design their own, choosing to explore different paths of these ideas. And further development of Gobstones is possible. We are using currently at advanced programming for university level. So we, for example, use them for teaching some basic data structures. It's already done. And we have some other idea for development. And you can design courses for other topics. We have some basic course on computer architecture, for example, using Gobstones. You can think about pattern recognition, algebra, several other stuff you can be teaching with Gobstones. For example, you can program robots. It's not done at the present, but we are researching about that. So all this shows that if you want to teach computational thinking ideas, you have to invest on good things that produce results. Thank you.
Thank you. Am I back, Richelle?
Yes, you are back.
Okay, we move forward. So our offering, how do we implement that? As Fidel just demonstrated, we have the complete curriculum, all the cycles books, coding tools and exercises from the age of 6 to the university level. Not only that, we don't only have the in-class activities, we have students, challenges, and competitions. So we can have cross-schools competitions. What in the coding environment, we as professionals call it hackathons. We can have hackathons for students using our tools. We have the teacher's education that I will discuss in a second, and the implementation on the ground. So we offer it A to Z, including the tools, the education, but most importantly, that we really focus on the teachers. We built all the manuals for the teachers for themselves to run those programs. And it's very important also to mention that the teacher do not need to have prior disciplinary knowledge. You don't need computer science teachers or IT-related graduate teachers. Any teacher who's interested in the topics can, within following our curriculum program, can graduate and start teaching computational science. And our goal is within 7 months, this program will be able to run without our help, but only with our support, just when we add new curriculum or new tools. But Bahrain will be able to build this know-how internally and run it and it will run by itself without our intervention. Now, also discuss a bit another part of our offering. Christopher, you can, it's your slide, you can take over here.
Yes. I mean, coming back a little bit to what is the secret sauce of success here? Of course, it starts with a well-educated population and a skilled workforce. So what NowMatters Academy is now offering, and what we just got an excellent demonstration of, is how to ensure that we have the talents needed to build a sustainable industry. That's kind of the starting point. It's very important. But of course, what you also need to add on this is, of course, another 4 very important pillars. First of all, of course, you need to have the most important, the stakeholders and the influencers around in the ecosystem with you. That is, of course, important, and they will follow if you have the other pillars in place. First of all, of course, very common what we see in a lot of countries is that everything starts with government agencies. And I say, yes, they are needed, but that is not the most important part. It's not the focus thing. The most important part is actually enterprises and investors. Because you need to have the companies, the enterprises with you, because they are those who is creating the demand for the services that this new well-educated programmers is developing. Someone needs to use the software. When you have that, it will be easy also to attract foreign or, for example, Nordic software companies to establish themselves on the local market. If they have, first of all, access to local talents, there is, as we previously said, a huge demand for talents from the Nordic region. So that's the outstaffing opportunity. That is very, very important. But in the next step, there is also a possibility to actually be attractive to get relocated Nordic companies to the region. They will relocate if they have the talents. They will relocate even faster if they also have access to local customers and local investments. But you can also consider that with local customers and a local establishment, they also have a springboard to a market that is much bigger than the Nordic region. So this is the 5 pillars, and we have extensive knowledge about how to establish the right level of engagement from all these 5 pillars. But I say, just recall it needs to start with the education of the workforce and the engagement of the local enterprises and local investors. Over to Rabih.
Thank you, Christopher. Now, if we want to implement this project, there's an investment offer. NowMatters Bahrain Tech Ecosystem is, we call it, is a triple head opportunity. We have the STEAM education that we showcased it with Fidel. That's one part of it. We have the Nordic ecosystem in Bahrain that Christopher just showcased right now. And the byproduct of that ecosystem is we're gonna start creating startups. So in there we can generate revenue plus equity, and the outstaffing opportunity to meet the demand of the Nordic and the European Union is another opportunity. So with a $1 million investment for 50% equity in the NowMatters Bahrain tech ecosystem, this project is executable. And the timeline for that, it's a 9 months timeline. Day one, the first 2 months, we're going to do a due diligence of the local educational ecosystem, how the schools are working today, where to start. Then within 2 months, we can start with a pilot of 2 schools. Within 4 months, we can run with 10 schools. And by the end of the calendar year, 7 months, we can be ready on the second calendar year to have a national rollout. And during this time, within 9 months, we can launch the local ecosystem connected to the Nordic ecosystem. So it's a 9 months execution project. And thank you. And we take questions right now.
Thank you for presenting this exciting opportunity across. And we right now do not have any queries from the audience yet. But hopefully, if you could just share your email IDs, we could circulate this, and then we'll see how it goes on from there. So thank you, dear panelists, for taking the time out to express this opportunity to us in this region. And we also thank all our audience to actually taking the time out to be present and for watching this. And we hope that you participate in our upcoming workshops and webinars as well. So thank you, dear panelists, once again.
Thank you.